Billions of dollars, years of work, the brightest minds on the planet, and yet, total failure. Some of the biggest scientific experiments ever attempted promised to change everything. But instead, they crashed and burned. Today, we're uncovering 10 of the most expensive science experiments that failed miserably. What went wrong? And could they have changed the world if they'd succeeded? Let's dive in. What if the key to unlocking the universe's biggest secrets was buried underground? Unfinished. In the 1980s, the superconducting super collider was set to be the largest particle accelerator ever, right in Texas. It promised to uncover mysteries that could change everything. But after burning through $2 billion, only 14 miles of its planned 54-mile loop were dug before Congress shut it down in 1993. Mismanagement, spiraling costs, and political chaos destroyed the dream. The result? A half-built tunnel, an eerie reminder of a project that could have made CERN's Large Hadron Collider look small. What happens when a $327.6 million mission goes horribly wrong? Enter the Mars Climate Orbiter, which crashed into Mars in 1999 due to a shocking mistake. Two teams used different measurement systems. NASA calculated in metric, while a subcontractor stuck to imperial. This simple mix-up caused the orbiter to descend too low, burning up in the Martian atmosphere. Years of planning and a chance to transform our understanding of Mars were lost in an instant. A costly reminder that even small errors can lead to monumental failures. Imagine a mission to Mars that never makes it off Earth. That's what happened with Russia's Phobos Grunt, designed to gather soil samples from Phobos, one of Mars's moons. Launched in 2011, it quickly faced disaster, becoming trapped in Earth's orbit. Despite desperate attempts to regain contact, it was declared a failure. The $163 million mission ended in flames as the spacecraft burned up upon re-entry. A golden opportunity to explore Mars's moon vanished before it even had a chance to leave. What happens when a groundbreaking space project fails? Meet NASA's X-33 spaceplane, designed to revolutionize space travel. Backed by NASA and Lockheed Martin, it aimed to make space missions cheaper and more efficient. But after investing $1.3 billion, the project was abandoned in 2001. The reason? Technical challenges with the fuel tanks. The composite material used for the tanks cracked under pressure, leading to delays and skyrocketing costs. Instead of changing the game for space exploration, the X-33 ended up as another costly failure. What if you could create a mini-Earth to support life on another planet? That was the ambitious vision behind Biosphere 2, built in Arizona in the 1990s with $200 million from private investors. This closed ecosystem aimed to replicate Earth's environment. But once the scientists sealed themselves inside, things quickly went wrong. Oxygen levels dropped, plants and animals began to perish, and the inhabitants struggled to survive. What started as a groundbreaking experiment turned into a nightmare. While it provided valuable data about ecosystems, Biosphere 2 ultimately failed to achieve its goal of sustaining life off Earth. Can you imagine an actual flying saucer? That was the goal of the U.S. Air Force's Project 1794, an ambitious attempt to create a disc-shaped aircraft capable of vertical takeoff and speeds up to Mach 4. In the 1950s, they collaborated with Avro Canada to design this futuristic aircraft. However, after pouring $26.6 million into the project, it was ultimately scrapped. Test flights revealed a major flaw. The saucer was unstable and impossible to control, failing to reach the high speeds it promised. What could have been a revolutionary leap in aviation turned into a costly flop. What if we could replicate the sun's energy on Earth? That's the ambitious goal of ITER, one of history's largest energy experiments. Designed to achieve nuclear fusion and provide limitless, clean energy, it sounds like a dream come true. But since starting in 1985, costs have skyrocketed to an eye-popping $65 billion. With ongoing construction delays, technical challenges, and budget overruns, ITER hasn't yet reached its goal. While the project is still active, many critics doubt it will ever deliver on its promise, making it one of the most expensive and controversial scientific projects ever. What if a satellite could unlock the secrets of Einstein's theory of relativity? That was the aim of Gravity Probe B, launched in 2004 with a budget of $750 million, after decades of planning. However, once in orbit, the mission faced unexpected technical issues that caused significant delays. While some data was collected, the results were far less conclusive than anticipated. Though it wasn't a complete failure, its high cost and limited scientific returns make it one of the more disappointing space projects in recent history. Hubble is a marvel today, but its launch was a dramatic disaster. Launched in 1990 with a staggering $1.5 billion price tag, the telescope faced a shocking setback. Its main mirror was flawed, leading to blurry images that left scientists reeling. It took 3 long years and a high-stakes repair mission in 1993 to make things right. While Hubble ultimately transformed our understanding of the cosmos, its rocky start became one of NASA's most costly and embarrassing moments. What could have been a groundbreaking achievement was almost derailed before it even began. What if nuclear power could propel us to Mars? That was the vision behind NERVA, a groundbreaking rocket engine developed in the 1960s to enable long-term space exploration. With an impressive investment of around $145 billion in today's dollars, initial test results sparked excitement and hope. But just as the dream seemed within reach, NERVA was abruptly canceled in the early 1970s due to budget cuts and shifting political priorities. The vision of nuclear-powered space travel was left stranded on the launch pad, a tantalizing promise of the cosmos that never took flight. So, what do these failures teach us? Science is risky, and progress is built on the back of failure. But when the stakes are this high, you have to ask, are we learning enough to justify the costs? What do you think? Was it worth it? Drop your thoughts in the comments, and don't forget to subscribe for more deep dives into the world of science.